Hi, I'm here with Michael Bolotski. He is the Research Engineering Manager at Meta Reality Labs, and I'm here to interview him about his job.
Pleasure to be here, Asher.
So, what's your background and what do you major in?
I majored in computer engineering at the University of British Columbia, and then I went on to do my master's, also computer engineering there, and then did my PhD at MIT Artificial Intelligence Lab in what they call EECS, which is a combination of electrical engineering and computer science.
And what was your first engineering job?
It's a good question. My first intern job was at a flight simulation company in Montreal. It was called CA Electronics. They did military and commercial flight simulators. But that was internship. My true full-time job actually was a startup that a friend of mine founded after graduating at MIT. And I started out as being the fourth person in the entire company, and then I ended up leading an engineering team of about 25 people 5 or 6 years later.
Yeah. And what does a typical day on your current job look like?
That's a complicated question because no 2 days are alike. I'm an engineering manager, which means that I oversee the work of a number of engineers. And actually, I'm what they Meta calls M2 manager. So I have managers who work for me. So a typical day is I don't do any hands-on engineering design, but I do reviews. So when an engineer has an idea for a piece of software, they write a document describing it, and they review it with me. There's about 2 of those a week. I do one-on-ones, which is conversations with specific engineers saying, hey, how's it working? What can I help you on? What are the risks that you see? I sit in a number of team meetings, probably almost too many, but probably about 5, 6 a week of either status updates or what should we do, or hey, there's university asking for a feature from one of research products. So it's a mixture. It varies across. About once or twice a month, I fly to visit remote teams and do the same kind of conversations and figure out strategy. So that's basically it.
And do you have a favorite part or maybe least favorite part about your job?
Um, so engineering, as an engineering manager, the least part of my job is uh, working with people who aren't doing good work, who aren't. We have to do what's called performance management, is figure out whether they can stay there or not, whether they can improve, or basically they're at the bottom of the scale, and telling people that they're not doing as well as they think they are, because everyone thinks that they're good, and basically educate them that they're not, and making a plan. That's my least favorite part. Um, Otherwise, you asked the least favorite.
Or what's maybe your favorite part?
The favorite part. I have lots of favorite parts. One of them is as a manager at Meta, supporting people. You get to sort of map out their career path. You get to coach them. Hey, do this better. Good job on this. Do this part. I like resolving ambiguity sometimes in a project. We don't quite know what's going on, and the team is kind of flailing around a bit or uncertain, like guiding them on how to solve problems and watching a team emerge at getting better. That's my favorite part of the job. Looking long range things, a lot of times the engineering team is focused on now, because they have to deliver something in the near term. But stepping away from that and saying, that's nice, but what should we be doing? What should we be aiming for a year from now or 8 months from now? And establishing that picture of the next sort of castle to conquer. That's fun.
So, how much do you use your major in your job?
Quite a bit, actually. I don't use my major to design things, but I use my major to understand the problems that are people having and suggest alternate paths. So what I do at what I do at Meta Reality is now I worked on a very what they call cross-disciplinary thing, the smart glasses that people wear, where there's mechanical, electrical, software engineering, firmware engineering, a little bit of optics. All those things have to interact to get something as complicated as glasses to work. So um, sometimes I use my electrical engineering knowledge for how chips work. Sometimes I go back to what I did my PhD, which is computer vision. I understand how computer vision interacts with us. So I don't dive in and solve the problems themselves. I'd be kind of rusty at it. I haven't done hands-on development like myself in maybe 5 years, but I know how to ask the right questions of the engineers doing the work, and their answers make sense to me. So essentially, I use my background every day.
Yeah. You said something about those glasses. What are those?
Oh, I work on, they used to be called augmented reality glasses, but there's a research version. So these are glasses that have multiple cameras in them, that have cameras that track your eyes so that you can see where you're looking. There's cameras that look down at your hands so you can see what your hand position is, and cameras that look outside in the world and essentially do what's called SLAM, simultaneous localization and mapping, which means they're kind of like an indoor GPS, but they also build up a representation of walls, objects, etc., so that AI can do it afterwards. And then with the RGB, the color camera they have, you can actually send images to a large language model, Gen AI things, so you can ask people can ask questions about the environment. So these are uh, these are leading edge. There's nothing out there. They're not a product. They're for research use. We're going to make a few thousand of them. But the things that we learn from that will inform Meta's product roadmap. Um, it's engineering marvel. Actually, I think this is probably the densest amount of sensors and compute packed into eyeglass form factor without meeting all the thermal requirements because you just get hot. Meeting the weight so the battery lasts a long time. It's a very challenging, very fun design point.
And what surprised you about this field of work?
Um, Interesting question. I think what surprised me is a degree to what fundamentals matter. So, I finished my undergrad in 1988, so solid, whatever, 42 years ago, right? 46 years ago. Anyway, a long time ago. And then my PhD like 96. But the concepts and everything from computer architecture to how transistors work, the math, um, all that still applies. Machine learning is brand new, but as far as the other 90% of the work building the glasses up until the point that the machine learning takes over, um, it's not exactly the same. Computers got more than 1,000 times faster. But the way to think about the problems, the way to think about data moving from here to there, the thing about doing signaling or noise, that all has stayed the same. I mean, the math behind it, the physics behind it, that doesn't change. So I'm surprised how, even though I'm in some senses 30, 40 years out of date, how that knowledge still maps to today.
So, what traits would you say are really important for someone to have in your field of work?
I think for an engineer doing in our kind of environment, which is research engineering, um, well, you have to be solid in your technical skills, obviously, but the character traits, I would say, dealing with ambiguity, being able to something is uncertain. Great. How do I make a plan to discover what we don't know and make a series of investigations to narrow things down. I think being technically fearless is good. If someone's multiple times people on my team get a brand new assignment they've never done before, they don't panic. They're like, oh no, we haven't done this. They just say, look, oh, let's go. How do I learn? How do I find the right expert? How do I get the right training? Speed of execution matters. What Amazon and Meta would call bias for action. In other words, you could be spending a lot of time on planning and reading and whatever. So at the end of the day, you have to try things out. So you have to move quickly. So I think those three.
And do you know of like any experiences or like things that you'd look for in a new hire?
Yeah, I've interviewed many. That's a great question. I've interviewed many, many people. Um, I could take half an hour on this answer, but let me speed it up. So book learning isn't enough. We don't only look for grades because for grades we can't tell whether how much independence you have, how much motivation you have. We know you're smart, but then everyone's applying is smart. So what we look for is individual study. We look for projects that you did of your own accord. We look for events like FRC actually, where a small team gets together and solves a complex problem where they're a little out of their depth. We look for things that you've started rather than being sent to, right? So, you could have attended a summer camp or a specialty because your company or when you're younger, your parents sent you. That's not on its own that interesting because it wasn't your initiative. So we look at examples for initiative, curiosity, and a willingness to learn.
And do you know of like a what a typical day on an entry level job in this field would look like?
Um, yeah, so an entry level job, you tend to work as part of a team where there's a senior engineer and a number of sort of intermediate level engineers. And on an entry level job, uh, let's say you're doing software, which is most likely what you'll be doing. You're writing code. You're writing code. You're in my world, you're testing it on hardware and real glasses. So you'll be writing it, compiling it, deploying it onto the hardware itself, making sure it runs. Probably making sure it's on a simulator first, and then when that works, you put it onto the chips themselves and see if it works as expected. You'll be you'll be trying to understand what the features when a product person or a senior engineer says, "Hey, you should implement this," you're making a plan. You're writing how you would approach it. Sometimes requirements are ambiguous, and you have to go investigate what that actually means to what level of quality. Uh, so you're probably doing 70% programming. You're doing about 20% debugging, verification, then doing 10% trying to understand, refine, essentially refine the feature requests. And then there's the meetings and there's group dynamic, all the rest of that stuff. But when you're doing hands-on work, that's what it looks like.
Huh. And do you have any parting advice for a young person pursuing a STEM career?
I do get, I do. I would say, just reflecting on what I've just told you recently, do hands-on work, things where yourself can try and make sure it's a little harder. So you have to try hard instead of just follow. So following a series of instructions off a web page will teach you, but not it won't train you when there's no such page in existence. So do hands-on work, work in a team of people if possible instead of just by yourself, and explore breadth. When you're young, I would say don't just do only focus on one thing and do it really, really phenomenally well, but get a broad swath of experience so you know what you like and you build up the broad skill set.
All right. Well, thank you very much for your time.
My pleasure.